Okay, who can I pick on now? Jeremy, you let me know. Just play.
Yo, are there any Globers in this room right now?
I think so. We are all silly might be a Glober, but I don't know if he wants to be called out. He's working and stuff, but I think he might be Glober.
What's up?
Or believe in Globe.
I
Hello.
said I was asking if there's any Globers in here right now because I don't really see any names that I know.
Yeah, I'm a Glober. What's up?
Dude, have you checked out any of the Ether Cause content, man?
Not too much.
You really should, dude. If you're actually a person who wants to know whether they might be believing a lie their whole life, you should check it out.
Okay.
I mean, if you just want to like continue believing what you believe and you don't care whether it's true or not, you just want to believe it, then I mean, don't look at it, right? But
Yeah. How important is the truth for you? Yeah. Thank
Are
you.
you from the?
Go ahead.
No, I
I
said
was
I've
just gonna
done.
ask, are you from
I've done
the
a
Ether
test to
Cosmology
verify
channel?
it. So
y'all are both talking. What'd you say, silly?
I said I've done a test to verify it.
To verify what?
The whole globe thing.
What was your test?
Oh, the reciprocal zenith angle test.
That's really weird, man. That's really weird because it seems like if that's your bread and butter, then you would also think that you'd probably will be interested in the celestial theodolite presentation given by Ether Cause. Do you know
What does
about
that
that?
have to do with it?
Well, reciprocal zenith angles are a consequence of a couple different things. One of them being the hyperbolic geometry of our grid of vision, because as it tends towards the horizon, it compresses more and more, and it's a nonlinear relationship below about, I don't know, 20 degrees or so above the horizon. Once you start getting to lower angles, the compression becomes more exponentially great. And so this causes effects when you look at things that are far away or low to have apparent angle deviations. And also, simply the deviation due to local atmospherics can't be used as a consistent basis for a geometric claim. So basically, in other words, in short, optics by itself does not prove geometry. You need something that can relate optics to geometry directly. So reciprocal zenith angles don't do that because they're purely optical based and don't show any definitive geometric basis for their observations. The celestial theodolite, what it does is it uses a midpoint argument to force the line. So if we live on a curved surface, right, then that would mean that the ground has to curve away as we increase in distance away from the point. So if I look at a distant mountain peak, for example, right, on a flat baseline versus a curved baseline, that mountain peak's going to be at two different angles. Now, if we just simply look at the mountain peak optically, we will see that it's usually neither exactly the flat baseline or the curved baseline, but it does trend closer to the curved baseline most of the time. However, what we can do is we can add a third point, right? Because currently we only have 2 points. We can add a third point behind the mountain and force a line between all 3 points. And what we'll use for that third point is a star. So we can use the mountain, basically. We can treat the mountain and pretend that the mountain is our theodolite, and we'll use the mountain to side in on the star. So what we'll do is we'll pick a star and we'll wait and we'll take a time-lapse footage with a video camera of the night sky, and we'll wait for some star to cross the mountain peak. Okay, and we can use stellarium to figure out what star that is. And the very exact moment that we watch on our camera that star cross the mountain peak and disappear behind it, at that same point in time, that's going to be the time we write down. Now we go to stellarium. We change our observer location to the mountain peak, and then we plug in that time and we look at that star and see what the angle is. And whatever the angle it gives us, guess what? That will actually be the same exact angle to the mountain peak from our observer location using a flat baseline every time.
So why are you allowed to use optical measurements and I'm not?
It's because the star does not disappear behind mirages, right? Like if there's refraction taking place causing the apparent position of the mountain to change, that doesn't matter because the star can only ever disappear behind where the physical mountain truly is.
What do you
Only
think a reciprocal zenith angle test is?
What'd you say?
What do you think a reciprocal zenith angle test is?
It's a measurement of. I could tell him, but go ahead.
No. Because
Yeah, it's where you're calculating multiple zeniths and adding the angles up to get 180 degrees. And if you get something different than 180 degrees, you presume the deviation to be because the baseline's curved and you're not on a flat surface.
okay, yeah,
More simplified though. More to be more like exactly what it is. It's a measurement of like, when they'll go to a mountain and say, oh, this other mountain's higher in elevation, but it's dropping, but it's, we made a horizontal and it's dropping. That's basically what it is. It's just things optically dropping in the distance. That's all reciprocal zenith angles are.
Well, it shows that plumb lines diverge.
Nope, it shows that
Oh,
things
do not
optically
diverge.
drop. That's not what
Yeah,
it shows. It shows that things
is what it
optically
shows.
drop. It shows that things are optically dropping in the distance. If you don't have any of the optical drop, you would get 180 degrees.
Okay, yeah, but the reason is because, like, if the Earth's curve is surface, that would mean plumb lines are diverging. So
Yeah, but
that's
that's terrible logic though, because it could also be if things are optically dropping, then you would also get this measurement on a flat Earth.
Yeah, it's a modus tollens logical error.
On a flat
So
Earth, you would get the 180 degrees.
it's a
If
modus
things weren't
tollens logical
optically
error.
dropping, hold on, Piezo, real quick. Sorry. Yo, I want to hear about the AU thing too, dude. I sent you a DM, but I'd love for you to go over it in here. But if we're on a flat Earth and things don't optically drop, you get the $1.80. Your logic sucks, basically.
Yeah, so the logical flaw is you're like, if A then B, oh, B then A. But it doesn't work that way. You're saying if the Earth was curved, then reciprocal zenith angles would add up to not 180. We took a reciprocal zenith measurement angle, it wasn't 180, therefore the Earth is curved. But that's not proper logic.
Consequent.
Right. I could say if
it just means the plumb lines are diverging.
Hold on. I could say
it could be like it doesn't necessarily mean that the Earth is curved. You're right. There could be a large mass. There could be a very large mass that's attracting. There
could be many reasons, bro. I could say if it is spring, the birds outside will sing. The birds outside are singing, therefore it is spring. But birds don't only sing in spring. So I can't just say it's spring.
You're right in the sense that it doesn't necessarily mean a curved Earth. What it could mean is that there's a very large mass underneath the flat Earth, which is causing the plumb lines to do what they do.
So do you know what the geoid model does with these? So basically, they say plumb lines diverge not because of reciprocal zenith angles. They say because those don't even match the geoid anyway. But the geoid, they went out and did these tests, right? They had the nautical almanac where they claimed to have already known the true position of all the stars, and then they went out to build a more accurate map under order of the Queen and the the royal family in England. And so when they went out to do this, they went to a bunch of locations on Earth and took zenith angle measurements to their stars. And they found that compared to the nautical almanac, the positions they actually saw the stars in were not there. They were slightly off. So they said,
the Mason-Dixon line with Pennsylvania, right?
No. They said, this is so weird that must mean that the water level that we're using to level our telescope is actually tilted because the gravity is pulling it off center. So we think that our telescopes are leveled, but they're not actually leveled. So there's a gravitational potential anomaly here. Instead
Yeah,
of just
this was
saying that
this
maybe
was
our map is slightly wrong, maybe our star position is slightly wrong, they said no, level's not level.
yeah, one of the first times this was observed was during the Mason-Dixon line, and that was ordered by like the queens or whatever, the royalty. So like I feel like that's what you're talking about. And then the person that was one that like read up on the report, one of the persons was Cavendish, which led to him doing the Cavendish experiment to see if mass is attracting mass.
Yeah, I'm talking about when they set out to actually correct the world maps and make them like as precise as possible. But there could be some relation there. I'm not familiar with the Mason-Dixon line. The point is, bro, the point is that a normal person with a normal logical working brain who wasn't already stuck, on one idea, if they went out and they said, we're going to confirm our map by measuring the angle to the star at this point, and they have star charts, right? They have star charts from like the 16 and 1700s. Then they go out to that location. They look up in the sky to see the star where it's supposed to be right above them. And instead of it being right above them, it's slightly off to the left. They're like, you know what? It's not that our star charts are wrong or our map is wrong. It's that gravity is not pulling everything straight here. No person with a logical, rational thinking mind would have that as their default go-to answer. A rational person would say, maybe the angle to the star that we had from 300 years ago is slightly off, and maybe our map needs to corrected. But no, they didn't say that. They said gravity itself is not pulling things down straight here.
No, they were noticing the error with their backsights.
Bro, their zenith angle measurements to the stars weren't
But,
showing the
but,
stars
but
at zenith.
yeah, but the whole thing is they were noticing like the plumb lines were being affected because of their backside error.
Bro, no. Do you know?
Yeah,
Okay. Do you know what you do with the zenith
this
angle
is
measurement
about
to
the
the star?
Mason-Dixon line, and like, yeah, literally, this is what they figured out due to their
No,
backside.
they used the stars, bro. They weren't using theodolites to look at distant objects. We're talking about looking at a star in a leveled telescope. So you take a telescope and you use a spirit level, which is where you take two sets of water levels in two planes, and you level them both, and now your telescope is shooting perfectly straight up in the air. Okay. Now I can look through that telescope and I expect, based on the nautical almanac, a star to be centered in my telescope at this time. But they found that the star was not centered at that time, it was slightly off. So instead of saying our star chart or our map position is slightly off, they said gravity is off.
Are you talking about the Schehalian experiment?
I'm talking about where they came up with the geoid model and gravitational potential deflections, which
Yeah, because this is like they would use it to figure out like their latitude. I know, but like, we,
right. So actually longitude, it was actually for longitude. So the board longitude, right, was made up by the Board of Longitude, and they had to go out and do a world survey in order to make their things accurate. And actually, the Royal House of England instituted a dictate that said anyone in the world that's making a map has to use our system for it under penalty of death. Right? So they made up this longitude system that they had their royal observers and surveyors confirm. And when the royal observers and surveyors went out to these places, they expected to see stars at zenith, but the stars weren't at zenith. So instead of saying that their previous data was wrong, they said that gravity wasn't pulling things straight. That's what happened. You can look at the presentations, bro. Look at Ether Cause. Look at Shane St. Pierre. Like there's plenty of presentations on the history of this. It's actually insane what they did, and people just aren't informed about like how wild what they actually did was. Because if people knew, like, wait a second, like, I mean, dude, it's just basic logic would not lead you to say that our data from 200 years ago is definitely right. Gravity is wrong here. I mean, that already creates such a logical conundrum, because if that's the case, how did you ever measure it accurately in the first place? You have no like empirical standalone basis for claiming the accuracy of the data at that point. But a logical person wouldn't say gravity must not be level here. Like, but I think it's easier to talk about other things, bro, than this, because this is an argument that really gets lost in the weeds because there's so many fine details to it, and there's way easier ways to overcome like the paradigm. We can start with the fact that objectively speaking, Earth is absolutely fixed and is not moving, and that can be measured.
Yeah, it has been measured 15 degrees per hour.
Well, that's just a relative rotation. That doesn't mean that the Earth's rotating, right? The rotational measurement using a ring laser from Michelson-Gill-Pearson in 1928, and ring laser gyros nowadays are sensitive enough to do it as well. But either way, all you know is that something is rotating. We would posit that rotation that you see of 15 degrees per hour roughly is the rotation of the ether, because the entire sky is rotating around. The Earth is fixed below it. See, in order to tell whether the Earth is moving or not, you can't just use a rotational argument. You actually have to use a translational argument, because they say Earth's not only rotating, right? They say it's also flying through space. It's translating through space in linear motion. So you can use a setup to measure the linear component and see what you get. But they tried that and they did not get the requisite velocity needed for Earth to be moving through space. No terrestrial experiment has ever shown any motion of Earth. You can even look up Einstein for a quote for that.
Mhm.
All attempts have failed. Now, we can fast forward to the modern day. It is now accepted and known within those well versed in the optics community that the linear motion can be detected with interferometry now. We have generalized the Sagnac effect. That 15 degrees per hour rotation you're talking about, that's based off something called the Sagnac effect, which is how interferometers, ring laser gyroscopes work, right? The Sagnac effect. But it was previously thought that the Sagnac effect only applied to rotation. And over 20 years ago, it was demonstrated that actually it applies to all motion. Translation also produces a fringe shift. So we know if something moves in a straight line, it'll produce a fringe shift in my lasers.
What does the
But
ether have to do with how I think it's like one of Jupiter's moons, like basically it varies at 6 months because Earth is going around the sun, but the time where the moon comes, like one of Jupiter's moons comes back out from behind it to be seen. There's like a 20-minute difference, and it's because of the speed of light, the time it takes for the sun, for that light to reach the Earth.
I think you're
During
talking about a 22-minute difference, but it's actually supposed to be 16. And that's something we were actually looking into a couple weeks ago, because old Romer claimed to have done it in 1768 or so, but his data was destroyed. We don't have his original data. He was an astronomer royal, and it burned up in some great fire or something, as it always does. And then people claim to have done a reproduction of it in 1817. There was a
okay,
guy.
so how does the ether cause that?
Well, first of all, that measurement itself, right, is entirely dubious and disputed, because we can use
No, it's
modern
not.
stellarium data today. We can use modern stellarium data today to compute it. And like I could show you a video right now of someone using the stellarium ephemerides from the ESA satellite network to do it. And he got 22 minutes as well.
What do you mean?
And it should be 16. So there's not really any correlation there. It seems to be a mischaracterization of history. What Romer actually found is that the speed of light was finite, not infinite, but he didn't actually determine any definite value for it. Now, as far as other observations besides Jupiter's moons, because that's about the ratio there of the speed of light difference at different points in orbit, you can say other bodies are just in different positions every 6 months, but that's due to From a geocentric position, the sky rotates once every 12 months. So 6 months later, it would be on the left. 6 months later, it would be on the right. So instead of having two intersecting lines forming the point of a triangle, you'd have two diverging lines with the point of the triangle at your feet. It's just geometry. It's geocentrism and heliocentrism are kinematically equivalent. And this is well accepted even in the relativity community. It's actually one of the backbones of relativity. The point is, though, back to the lasers, bro. We can measure linear motion with lasers. We know that if something moves, we can detect it. But we don't get any reading like that for the Earth.
Yes, we do. We get 15 degrees per hour.
That's rotation. That's not translation. Do you know the difference?
Is it movement?
Okay. Rotation is rotating in a... Yes.
Sure, I don't care. Is it movement?
But it's not the Earth rotating. That's the point. Are you following? You're not following.
No, I'm not following.
There's two distinct types of motion. There's translation, which is like a conveyor belt moving in a straight line. Okay. And there's rotation, which is spinning around in a circle. Okay. Rotation is measured in radians or degrees, and translation is measured in length. So rotation is like 15 degrees per hour. Translation is 60 miles per hour, right?
But does anything
Why
even
do we see different
travel
stars?
ultimately in a translational fashion? Like, I don't think anything in the universe travels in a straight vector without eventually turning.
At any point, though, it's always moving. At any point across any sufficiently short window of time, it's effectively linear. If you take something that's going around a giant, 180 million mile arc or circle over a year, over the period of any second or 2 seconds or 3 seconds or however long you want to make that period of time, over any period of time,
It's translational.
Yeah.
I got you. But ultimately, right? Ultimately, nothing's translational. Everything is curvilinear to the mass.
Well, that's what they say, but how far off of a straight line do you need for it to not be linear anymore? Right? Because we can trace the difference. We can use GPS signals to trace the difference across like two cities, like Los Angeles to New York, and the deviation in like the signal height across that distance is like a few microns. And no one in their right mind would say a deviation of a few microns over 3,000 miles would make it not straight.
Well, that's how we get into the level versus horizontal conversations, I guess.
Well, if a few microns across 3,000 miles makes it not linear motion, then linear motion doesn't exist, bro. Like,
It doesn't. That's what I'm saying. Like, ultimately, on the macro scale, it doesn't. Maybe on the micro scale, sure.
That's the point, though. That's the point of the Sagnac effect being generalized. It was shown that you can do it with conveyor belts, and it still shows a velocity proportional friend shift. And so the point being, if we know we can detect it, and we don't detect it with Earth, Earth's not doing it.
Right.
Let's say that together. Earth.
All right, Captain Planet.
But still, you really need to learn the relative motion arguments of relativity. You need to learn the postulates of relativity. You can learn all that from ether cause, because if relativity is not true...
The postulates? What? The postulates? Really?
Yeah.
You don't even hide.
If relativity
it's the same thing as a theory, just more of a...
This is the danger.
Right? A postulate is like a theory, right? Just more substantiated.
Wow, religion sure has hidden itself in academia quite well, I guess. I profess that.
If relativity is not true, silly, then you don't live on a spinning, wobbling, orbiting space ball.
I am definitely a silly.
No, I'm talking to We Are All Silly. That's his name. His name is Silly. But you should look at the history of science. The reason relativity came into existence is because some dudes measured light to try to measure Earth moving through space and couldn't measure it moving through space. They failed to measure it. And so for 18 years, everyone was freaking out and they were like, what the heck are we going to do? This doesn't make any sense. Like we can't measure the motion. It has to be there. It's not there. Where is it? And then Einstein came along and was like, you know what? We're just going to say that the speed of light is always constant all the time. And they were like, well, how can we do that if stuff's moving? He's like, well, because if stuff moves, then it also shrinks relative to how much it moves in order to keep light the same all the time. The universe just magically knows exactly how much to shrink and stretch everything so that no matter how fast or slow it moves, it all changes in real time to make sure C stays C. And the speed of light doesn't change.
But we do observe like time dilation, so
I mean, you didn't know that nature keeps a journal, Piezo?
I mean, it's actual brain rot, dude. I can show you the Encyclopedia Britannica from 1937, 32 years. 32 years after Einstein came out with his special theory, 20 years after he came out with his general theory. And it says in that encyclopedia, 32 years later, it's still discussing the ether as being valid and Einstein's theory of relativity as being confusing and weird.
Okay, but time
that's the actual brain rot of belief, you see. It is what happens.
It's not a belief. It's like, am I muted or something?
You were.
No, we hear you.
Time dilation is an observed effect.
How is it observed? Please tell me how it's observed.
With satellites.
Oh, yeah? Oh, man. Oh, man. Okay. How is time dilation observed in satellites? Go.
Because the clocks don't match up with the ones on Earth.
So, okay, we're doing modus tollens again. We just did this earlier with the reciprocal zenith angles. If time dilation was real, we would expect clocks to change. Clocks change, therefore time dilation is real. That's an invalid argument.
No. That's not what he's saying. First of all, he's saying because he could use a machine for how he's told its use is for, he now saw something beyond his own sight or senses.
Well, let's let him decipher that in his own words, Siak. Go ahead there. We're all silly.
Like I said, it's an observed effect with equipment.
So let me tell you, it's funny. I just finished reading some GPS papers for like an hour and a half this morning. So let me actually talk about this a little bit because that's actually what I wanted to come in here and talk about when I first joined. It's funny we got there. So GPS, right? It uses what's called.
Okay, I'll be audience. Sorry, there you go. See,
GPS uses what? Thanks, bro. GPS uses what's called a pseudo-range equation. And so basically what it does is it calculates your position using a velocity equals distance over time relationship. And that is how it pinpoints your location. Now, in order to do that, there are several corrections that have to be made because stuff is moving all the time, right? They actually do a Sagnac correction, go figure, where they claim to be adjusting for the rotation rate of the Earth. In our paradigm, it would just be the fact that the sky is spinning. Either way, they do a Sagnac correction. They do a second correction for the relative velocity between the satellite and the receiver on the ground. So let's say you're in a moving car driving down the highway at 60 miles an hour and there's a satellite orbiting above you at like 8,000 miles an hour. They take the relative velocity between you and the satellite and they compute that in the signal timing delay in the pseudo range. Now, the problem with that is...
Are you saying they work it in on the back end, not in actuality?
No, it's not on the back end. This is incorporated into the math. The problem with this is all of these calculations are done in the Earth-centered, Earth-fixed inertial frame. So it's a stationary Earth frame in which the satellite is moving and the dude in his car is moving, and you draw a straight line between those 2 points, and you take their velocities, the relative velocity between them, and you incorporate that onto by adding or subtracting it from the speed of light. So there's a c plus or minus v relationship implicitly tied into that equation there because you're accounting for the relative motion between source and receiver. GPS does this every day. Every time you ping your location, it does this. It's all the time happening. So that is already a direct refutation of relativity on its face because it says right in Einstein's paper in 1905 that the speed of light does not depend on the state of motion or the relative motion between the source and the observer. Yet they're accounting for it mathematically every time that you ping your cell phone location. So the fact that they're doing that already refutes relativity. Now, as far as the time dilation component goes, that's in affirming the consequent because people already figured out based on the principles of relativity, use it that based on how fast the satellites are moving, there would be about a 7.8 microsecond delay because of special relativity. And based on the gravitational potential at that altitude, there would be like a 45 point something second advance, microsecond advance. So altogether, you add those together, and it's like 38 microseconds faster. Okay, and they say at 38 microseconds faster in one day, we would accrue an error of thousands of kilometers in our position. We'd be completely off after a whole day. We don't see that error. Therefore, we know that they're using relativistic corrections. That's affirming the consequence because that's presuming relativity is true. And if it was true, it would have to be there, and it's not. So therefore, it's being corrected. But
So you're saying they just make it all up, basically.
Yeah, I'm saying that I can show you papers right now of several, scientists. We've got Aerospace Corporation and all kinds of other people, U.S. Naval Observatory people talking in a Q&A at the end of the paper after the paper explicitly makes it clear that there are no relativistic corrections in the actual satellite software. Nowhere in any of the software is there.
Well, that's why I said they crunch it in on the back end, bro. And you said no.
No, it's not on the back end. I'll explain. Nowhere in any of the software are there any coefficients for a relativity correction. There are no relativity corrections anywhere in there at all. What they say is that the U.S. Space Force, because they're the ones that operate the GPS now, and other people sent the satellites up before them. So whoever it was that sent them up, the people that sent the satellites up before they sent them up, they adjusted the cesium clocks inside the satellite by adjusting them by a rate of about 4 times 10 to the negative 10th power hertz, so that once they started moving and experienced time dilation, it would balance out and equal the frequency on the ground, so there would be no frequency displacement. It is none of us can ever verify that. It's not in. There's no code for it. They claim it's already cooked into the hardware side, in the hardware configuration. And that's all classified and proprietary and operated by the military. And the only people who would know it would be the actual individual programmer who individually adjusted the oscillation frequency of the cesium clock on the day it was launched.
I mean, how would you consider that they would be able to move a cesium atom? I mean, a minuscule amount to adjust for that. Like, that sounds like I don't know,
it's a correction on the order of 10 to the negative 10th power.
It's crazy, bro.
But we don't even need to necessarily get into that because I would say that just didn't happen and they didn't make that correction. We
so
can look at the
fact on the back end.
It's not the back end; it's in the hardware. There's never a correction done. There's no correction done. It's just the clock is already adjusted so that any signal it sends out, it's already been time dilated already. So once it got time dilated, it's at the Earth frequency. So it's like.
So you're saying it's built into the mechanics somehow.
They claim that the cesium atom oscillation frequency, it has already been pre-tuned in the clock prior to the satellite being launched into orbit.
And that's amazing that it would be able to stay tuned like that.
So here's the problem. I'm able to use my surveying GPS thing to direct me back to a point which has been observed years ago.
Okay, and that doesn't go against anything I'm saying, bro. We know GPS works.
If it's filled with like relatively made up and all this stuff, like Like it wouldn't
Bro.
work.
My prediction, hey, check it out. In my paradigm, my prediction is that relativity doesn't exist, so no corrections for relativity need to be made. So my prediction is that if I look at the software, there won't be any relativity coefficients. When I look at the software, there's no relativity coefficient that matches my prediction. Why am I not the one that's correct? Right? So we have to look at something that's mutually exclusive, because this argument about the cesium clocks, neither one of us can prove it. So what's something we can look at that does lend credence to only one side? That's where I said, in the corrections, there is a correction that is made for the relative velocity between the satellite and the ground receiver. They are accounting in real time for the relative velocity difference between the satellite and the receiver. And this is being modulated onto or away from the speed of light. So we literally have c plus or minus v of the satellite being adjusted for in the formula. You cannot do that in relativity. C has to remain constant in the same inertial frame. So in the ECEF frame, C should always be C, but that's not what they do.
Yeah, if C wasn't C, we'd be able to get on a train, shoot a laser beam from the back of the train to the front of the train, stand on the ground, okay, it's C, make the train go forward, now shoot it from the back to the front, now it's C plus V. You can't
No,
Piezo's right, you can't do
yeah,
that in relativity, otherwise you're now breaking the speed of light. Yeah,
no,
plus
no.
V,
You
C
don't
plus
understand
V.
relativity. You don't understand how the
Oh,
speed
that's your rebuttal, you don't understand?
yeah,
That's
you don't
fucking
understand.
whack, dude. That's whack.
I
Do you
don't
have a real
fully understand.
rebuttal? Do you have a real
Basically,
rebuttal?
he was talking about the distance. What is it? Distance like dilation also starts to happen when you pick up the speed.
The satellites adjust for their own velocity through space in the Earth inertial frame. You can't do that in relativity. That literally fundamentally violates the postulates of relativity.
Like you could be traveling 99.9999999% the speed of light, and you shoot the laser, it still looks like it's going at the speed of light to you.
That's what relativity says, but what I'm telling you is you can look right now
Actually
at
observe
the
it too.
GPS code, and in the GPS code, they correct for the speed of the satellite in Earth's frame, in Earth's inertial frame.
Uh-huh.
So in where you are on the ground, wherever you are right now, if you treat Earth as stationary where you are, okay, you say, I'm rigid and I'm fixed in space and I'm not moving. I'm an inertial observer fixed to a non-moving Earth.
Now that I'm finished with the job, I realized we kind of digressed from the fact that you said I can't use optical measurements to prove anything, and yet you are allowed to for some reason.
What we're talking about electromagnetic wave propagation right now, bro. What do you mean optics?
Yeah, like I started talking about the reciprocal zenith angle test, and you said, well, you can't use optics to prove anything, basically. And then
Dude, are we going to talk about modus tollens for the third
you
time?
started talking about optics and everything to not really prove anything, but just to disprove relativity. So, do you have anything that proves the
This
flat
is
Earth?
optics, bro.
Do you have anything that proves the flat Earth?
Oh, he doesn't want to talk about what you're talking about anymore, it sounds like.
Yeah, like,
No, we talked about my stuff for quite what has it been, like 45 minutes to an hour?
When
I
are you going to
pretty much
concede, though?
you
You haven't
pretty much
capitulated. You just want to change the
this,
topic.
but like they started talking about the reciprocal zenith
this is what
angle
they
test.
always do, right? Like, they get to a point where they realize they're stuck and they have nothing to say, and they're like, well, let's go back to a different topic. Let's topic
The
jump.
theory, which led to the theory of relativity and Einstein and all this stuff. All this spawned off from a reciprocal zenith angle test.
You're spiraling, bro. You're spiraling.
Well, that's just what happened.
It didn't spawn off of a reciprocal zenith angle test. I sufficiently described the reason why that's not a mutually exclusive proof of anything. So we need to look at other evidences if we want to get a mutually exclusive proof of a paradigm. And
Okay, so
therefore,
what other evidences do you have that prove the flat Earth?
what do I have to prove?
Topic change.
Yeah, yes, it is a topic. Yes,
Well,
I
Climate
agree.
change. When are you going to concede to what all the information
I have this evidence that I presented to
you're
you
scared?
that Earth is not moving.
No, you tried to disprove other claims. You
You
haven't
just
made any
shared a
claims
whole bunch of
yourself.
information.
I did make a positive
Hold on,
claim.
Dice Low's roboting, guys. Hold on.
Why don't you just concede to that?
We have to wait for the guy that's roboting?
Yeah, or we could talk through him. I sent him to the hot mic room.
Yeah, I'd
Hold
rather
on.
talk through him.
So
Fixed.
the the positive claim that I made is that Earth is fixed and stationary and it's not moving and we can measure it as such. And then the evidence
How do
that
you
I
measure
invoked,
not moving? Like, what do you mean?
the
How
the
are you doing?
evidence. Were you present for the entire conversation leading up to immediately preceding GPS?
Using the mountain and a star that you know through this thing
No.
that
We talked
prehistoric
about
to the
laser
fact that
beams and
things aren't
bro,
moving.
are you being purposefully obtuse? Right before GPS, we talked about interferometry. Or were you just like not listening that whole time and now you want to try to act as if like it didn't happen?
No, I mean, you were going on for quite a little bit. First, it started talking about with the star going behind the mountain, and then it led into like,
No, interferometry.
yeah, that's one of the things you were talking about. The other thing was the star going behind the mountain.
Okay, you just asked me. You just said you haven't made any claims, and then
Did
I
you not
said
talk about
I
the
made a
star going?
claim. Here was my proof, and now you're talking about a theodolite. Do you see how that's a non sequitur and a red herring, and you're not even talking about what I just brought back as the point?
Okay, but that's what
This
you were.
dishonesty, bro.
Wait, I'm sorry. Did he not talk about a star going behind the mountain?
Bro, you just said you haven't
That's
even made any claims. And I said, yes, I have.
So,
I told you what my claim was, and then I reminded you of the evidence I presented, and you completely ignored what I said about the evidence I presented for it, and you started talking about the very first topic we talked about at the beginning.
Yeah.
Yeah, that's what you, okay. So, yeah, so that's what you just did is intellectually dishonest. Thanks for acknowledging you did it.
Why? I'm telling you what I want to talk about. Tell me how the
But what
tell me how the star going
are you going to
behind the
address the
mountain
points you just made?
also agrees with the Earth being stationary.
The star going behind the mountain, mathematically,
Tell me how that also agrees with the Earth being stationary. Yes.
it agrees with the Earth being flat. Because the flat baseline and the curved baseline predict two completely different times for when the star should disappear behind the mountain.
But why is the star going behind the mountain?
The star is going behind the mountain because the sky moves.
The whole sky is moving.
The entire sky, yes, is rotating.
And that's not part of Earth's motion?
No, Earth is not moving. Dude, in the paradigm you claim to believe in, you can't say that I'm wrong because all motion is relative.
Okay.
The census might
Welcome to
arrive
Flat Earth.
soon when it lands.
So the timing at when that star disappears behind the mountain, to say it again, on a flat baseline, it predicts a completely different time on the clock than for the curved baseline. And we can measure it and see which time actually occurs.
Approaching ground.
Yeah, I mean, Dr. Michael Heffron did these observations at like 7 different mountains. We've got like a couple dozen different star observations on a big spreadsheet if you want that too. It's all published on Allen's Space Audits Obsidian database. So you can see it for yourself and compute it for yourself. We also have the raw video footage so you can watch the video yourself and we can see the time that the star disappears behind the mountain and compare it to the flat and curved baseline, bro. And the flat and curved baseline, the flat and curved baselines are different by like in some cases they're off by like 20 something seconds.
How do you explain the sky not moving in uniform?
What do you
Supposing it
mean
is.
not? The sky uniformly rotates at 15 degrees per hour, roughly.
No, there's like comets and shooting stars and stuff like
So
that.
there's stuff in the sky that moves. I mean, the planets also do their own motion. The moon does its own motion.
Yeah,
The sun does it.
Yeah, it's
Okay,
not
yeah,
you.
there's
Exactly. Yeah, you get
bro.
it. It's not you.
Are you serious right now, bro? The entire sky has a fixed rotation, but within that fixed rotation, individual objects can also have their own individual motions as well.
Okay, let me help you out, man.
The Earth is one of those
He's
objects.
stuck. He's stuck at the place where he saw something measured to prediction,
Earth is one of those
and then
objects.
he did the measure. I'm getting spoken over.
I think he was still in the middle of talking, but we are still. You got a really bad connection. I don't know if that's just internal or intentional, so you can just kind of deviate away from the conversation. But you might want to fix it.
Okay, maybe clean your mic or get help from your wife. She's good at cleaning, I hope.
So for everybody else, I hope that people who weren't well versed on these topics learn something from this discussion, because ultimately, at the end of the day, it's for the benefit of everybody, not just a person wanting to be stubborn and clog this themselves and gaslight their own souls.
Okay, great. Well, let's not do that. Let's look at the sky. Okay, so let's look at the sky.
Yeah, I learned something, and I appreciate that. Appreciate all that information. It was a lot of information. I'm not sure I was able to retain all of it, so I don't know. I'd appreciate it if you could come back in, maybe at a later time and date, and refresh us up on that, because that was all beautifully put information.
What have y'all been talking about?
All sorts of
Are you
stuff.
from the Ether Cosmology channel?
Piezo, have you heard a good?
Yeah,
I'm
I'm over there.
Piezo, have you heard a rebuttal for the AU thing?
Can you guys hear me? Mike?
To the first guy, thank you. I appreciate it. You're very welcome. I don't know. I pop in at random times, but you can see all this information on Alan's channel and Shane's channel. And to Jeremy, so I looked into it. I think I covered it a little bit earlier, but I'll answer you more directly now. I looked into it. The data from Romer doesn't exist. We have a copy that was found of like some side notes he made. But it's not really useful. There was about 100 and something years worth of data after that, because it was like 1687 when Romer did it. So like 130 years later, in 1817, a guy named Delambre, or however you say it, tried to recreate it using Romer's method with the data they had at that point in time, and claimed to have done it accurately. The problem is it's very conspicuous because he makes some kind of arbitrary corrections, which we haven't been able quite to get to the bottom of what he actually did yet. He has like it's like 100 and something page document, and it's all written in French. And so we need to get it OCR'd and translated, and then break it down to see what he did. But in the meantime, well, it's because that's going to take some time to do that. Also, we would have to like verify all his stuff, and that would take as long as it took him. And he worked on this project for years. None of us have years to like go one by one through each of his like measurements on there for the ephemerides and compare them and make sure they're accurate. But we really just need to look at his method and see if his method works, and then we use stellarium with his method. But either way, we did have a video, which I think you saw it, from a guy who was like an astronomer who just used stellarium to, or maybe at the very least an astronomy person, if he doesn't work in observatory. He used stellarium and Romer's method to compute it himself, and he also got the same 22 minutes that Romer got. So it's very odd. I mean, once again, we don't have the step by steps of every specific thing in the method, because there are ever so minute. There's like ever so slight minute corrections that have to be made, and we can't find yet. Like, we haven't been able to find what those corrections are supposed to be in order to do it all ourselves to verify it. But either way, based on the accepted speed of light and the accepted orbital diameter of Earth around the sun, the time delay propagation over a year or over 6 months should be like 16 and a half minutes. And in reality, we have two sets of people's measurements saying that it's 22 minutes. So that is still up in the air. Like, we might not be able to do that unless we're able to find a very, very specific down to earth rendition of here's the method for making the corrections. Because whenever you measure it in Stellarium, I've done it myself in Stellarium, and I've gotten like 6 or 7 minutes, and apparently that value is supposed to be corrected somehow. And so I haven't been able to find how to do the correction to compute like what it becomes after correction, but it's not easy, man. It's so to give you the answer, we haven't really gotten a strict answer on that yet, but it seems very, very dubious at best currently.
Can I get a mic check?
Yeah, no doubt. No doubt. Just wondering if you heard a rebuttal. I was just wondering if you heard a rebuttal for it at all, or you guys hear me?
Oh, the rebuttal is that we just didn't do it right, and if we do it all correctly, then it'll work out to 16 minutes. Like, there's no real rebuttal. I mean,
it would depend on the relative position between Earth and Jupiter, then, wouldn't it? Since they both are orbiting, not at the same speed.
Am I coming through at all?
that's the thing. If that was the case, we would be able to do that using modern Stellarium data and the proper method and get an exact delay that would perfectly match the speed of light. But we don't have that. We have Romer's method used in 1687, getting 22 minutes. We have some guy who claimed to do it in 1817, and he said that he got 16 minutes, but he made some kind of arbitrary corrections that Romer didn't make. And it's dubious because at that time they had already figured out what the speed of light was by using the electric permittivity and magnetic permeability constants. So they had already computed it mathematically. Even though it hadn't been hand measured exactly yet, it was still computed. And then, so it would be very easy for him to just correct to the accepted value. And then, like I said, dude I found on YouTube has like a 5-minute video where he does it all in Stellarium and shows you. And he's like, I got 22 minutes, which is super weird considering that's the same value Romer got. I find it very odd how I could have potentially made the same mistake as he did using modern methods and tools. I don't know how to figure this out. If anybody knows what I did wrong or what the biggest source of error is, please let me know because I'm dying to know. I'm very curious. Like, he was confused because he's like, how did I get the same result as Romer? Right? It shouldn't be 22 minutes because that would imply that either the speed of light's wrong or the astronomical unit is off by like 33%. And you can't have that. Yeah, we can hear you.
Oh, cool. Finally. Are you from the Ether Cosmology channel?
I'll hang out in there.
Can you ask
you have something on topic? Yo, hold on, man. We're in the middle of something right here. Like, send me a DM.
I'm gonna let you get back to it. I gotta go in like 5 minutes.
Dude, we're getting back to it right now. You're not gonna let us do anything. What do you mean?
Dude, I've been waiting a half an hour to ask a simple question. 2 seconds and I'm gone. I just want to ask if you can ask around why I got banned because I showed up. Someone.
Anyways, carry on.
Yeah, I can ask Alan. But anyways, that's as far as I can currently get it. Like I said, it seems dubious at best. We have a modern reproduction of some guy in Stellarium. I don't know his exact method. It shows all the steps he takes, except for the slight correction he makes, and he talks about in the video description having to make that correction, but he doesn't. That's the one part of the video he doesn't show his method. So, like, as I said, I have, as of yet, not been able to find a source document that shows like the steps to make that correction. Because without the correction, you get like a completely different value, just using the raw timing at opposition and conjunction for Earth and Jupiter. So it's it's real interesting. So until that happens, I won't be able to do it myself, and the best I have to go off of is dude with Stellarium in 2022 or whatever it was, and some guy in 1817 wanting to say that, hey, astronomy's not broken after all.
But you see how that guy said the same thing I said when I first heard this. What about the orbit of Jupiter? Because it's not you know what I'm saying? It's like elliptical. So is ours. And their model.
Yeah, so the orbits of all the planets are elliptical because if you think about it, you have the sun going in a circle, right, around Earth. And then all the planets, or all the planets, go in big circles around the sun. But because the sun's moving and they're also moving, it stretches them at the ends and shrinks them at the midpoints. So that creates elliptical orbits for all the planets. I think I could be wrong. I'd have to dive more into this. The orbit of the sun around the Earth could just straight up be slightly elliptical. It might just be elliptical, and it just is because it is. But I think that, and I could be wrong on this. This is the part I'm not certain about. I think slight eccentricity could just simply be an artifact of like the computations that are being done in their frame. Because I'm not certain that in a geocentric coordinate system, in a geocentric model, that the sun is eccentric at all. I think it might just be a circle for the sun and everything else is elliptical. I have to verify that though.
What is a planet?
Just some kind of light up in the sky. I don't know what it's made of, bro. I don't think anybody does.
And what do? They you said they orbit one specifically? You seen that?
The lights in the sky move around in set patterns.
Oh, I'm aware they move around in set patterns, but have you physically seen one go behind the other? Did it go through it? Did it disappear?
Oh, they'll some of them will eclipse each other or occult each other. You can see.
Right, but does it go behind each other? Does it go through each other? Is it just lights? Is it phases? What is actually seen?
Well, I think that they're just at different altitudes. So I think that they all have their own circles or ellipses in the sky, and they're at different altitudes. So like the moon and Mercury and Venus would be at lower altitudes than the sun, and then the other planets would be at higher altitudes than the sun. And then at the very height of all this, at the very far back end, you have like the background stars. They're the highest.
Uh-huh. All right, man. All I see is lights.
Right, bro. That's all we actually know objectively is here's the lights and here's the time it takes them to move. I even think that there's a firmament. So what we see is just projections. I don't think it's possible to know the true positions of any of it. We see apparent positions of all those objects. And if anybody knows about like collimated projections, if you take a collimated projection and you adjust the distance of that like source relative to what you're projecting it on, like the wall, it doesn't change the size of the circle on the wall. So like if I project if I collimate like a light source into a circular disk of light onto the wall, I can adjust the distance to and from it, and it won't change the size of the circle. It'll still be the same circle size on the wall. So that would explain like why the sun's angular size remains the same. Because it's projecting, it's being collimated through the firmament.
I hate that word. People don't understand what it means.
What word?
Collimation. Most people don't understand what it means.
It's when a light source is focused.
I know what it is. It's one of the first things you have to do with a theodolite. It's something that gets skipped by everybody I've seen use a theodolite in these channels. First thing you do is you do your collimation test because you have to make sure that nothing has happened inside of your apparatus for your lenses to get out of alignment. Because once your lenses are in appropriate alignment, You don't have to worry about your optics being offset when you shift a little left, shift a little right, which can happen if your optics are not aligned, right? Because you're getting two different images sitting down the barrel because everything's not aligned. Which what collimation is an alignment. You're putting everything in alignment, basically. That's what collimation is.
Yeah. And in terms of light, it's usually done with prisms. In this case, for your theodolite, the prism is just glass, but you can a lot of projectors have like collimator systems in them, like the fancy ones. You can also get like collimation prisms that are just standalone, like a little piece of glass, basically a lens that's acts as a collimator, and you can shine a flashlight through it. You can move that flashlight forward or back behind it. It doesn't change the image on the wall.
Yeah, you also have collimation masks, where you very often use in reflector telescopes.
But anyways, boys, it was good chilling for a minute. I was cooking food, so now that my lunch is done and I'm eating it, I'm going to go eat and enjoy playing this remaster of Oblivion. I don't know if y'all ever had nostalgia from your childhood of Oblivion. They remastered it on Unreal Engine 5. So
Just try not to watch any more of those awful videos on your lunch break.
Videos about what?
My lunch break. I've watched them. They're awful.
Oh, that guy who's like theorizing about Tartaria.
Yeah, you were spreading that around. I've watched all that stuff. They're like I've run it down. It's unsubstantiated, every bit of it.
I wouldn't say it's all unsubstantiated. I think the majority of it is. Is basically there's little we can know for fact when it comes to like historical timelines 5-6 generations removed from us.
Oh. Yeah. If I pick up my great granddaddy's war journal from the Civil War, I think I can trust that on October the 2nd at some time he was on the march through Mobile, Alabama, as according to his diary. You know what I mean? Like, there's certain things like, yeah, they really were at war at that time. Here's my great ancestor on the march. Oh wait, here I got another one on the side of the family with the Union Army coming down from North Carolina. You know what I mean? Like yeah, these things happen. Like the diaries are still in my family in a war trunk, bro.
Sure, but does that diary say, hey, it's definitely not true that these buildings were already here when we got here, and that there's no photographic evidence of their construction other than at completion? Like that kind of stuff's not talked about like in people's diaries. Like engineering feats that are not commensurate with like the population size of tiny fur trapping towns out in the middle of the forest in Washington where before there were railroads, but they have like 50-foot tall, like 3-foot diameter marble pillars all the way around the building, and it's like things that were put in place and cut and carved and moved in a town of a population of a few thousand. It was like a trapping community. Like that kind of stuff is just crazy to me. Y'all basically built like the Parthenon out of marble out in the middle of the woods in Washington in a fur trapping community.
But they didn't. That's the thing that's fucking so hilarious about it is they didn't. People just that's how good the facade is, but it is a facade. Like that stuff, they are not stone like the ones over in Greece. They're not made of stone. They are made of wood, and they're made of lath and plaster, and then they put a facade on the outside and make it look like they're stone buildings.
I'm not talking about the World's Fair, dude. I'm talking about buildings that are still here, like Olympia,
I am
Washington.
too. I'm talking about
the Olympia, Washington Capitol building's still there, bro.
Oh, yeah, if you're talking about you're talking about downtown DC, but that's late 1800s, early 1900s. Yeah, Washington State.
Yeah, Washington State at the time was
Washington State Olympia building.
they said that building was built. The Capitol building was built in like 1910, and at that time the population was like 8 to 10,000.
It was built after World. It was built during World War I. Really, 1922 to 1928. It was a 6-year construction, and we already had steel ships at that time. We had rail. We already had trade with China and Japan. There was steam engine going across the ocean. Industry was booming. America was building industry while the rest of the world was at war. The rest of the world was in debt. America's industry was collecting all of that debt.
Look at the population at that time, bro. It was like 10K.
Yeah, I bet 2,000 of them were brought in just to build that building. It's probably only like an 8,000 population.
There's other ones like that crazy school out in like the middle of Minnesota somewhere, in a city of a population of like 1,000 people, and it was supposed to be a high school, and the high school population of the town would have been like 50 people, and it's like they built a castle for 50 kids. There's all kinds of examples, bro. But anyways,
I'd also be willing to bet that that's facade as well.
No, it's still there today.
Yeah, and I'm guarantee you that much of it is facade. Even like the White House, which was built in the 1800s and looks like it's marble and granite, it's not. It's a facade.
There's a 1,700 seat. There's a 1,700 seat grand ballroom in there that's built like an opera house with like concave ceiling panels and indentures with crystal chandeliers that are like with crystal from like over in Italy somewhere that they're $250,000 a piece. It's still there. Mm-hmm. And it was built in like 1890 something in a town with like 1,000 people to be a high school, they said.
Yeah, and I don't have a problem with that. I mean, if you're building something for the community you love, it's gonna be awesome. You know what I mean? Like I've known trim carpenters, cabinet makers, go to church, 70 years old, been working in people's houses and worked on all kinds of commercial projects, done all kinds of nice work, and when they get the chance to do something for their church, they blow your mind. And then you walk into this church, this podunk backwoods redneck church, and you walk inside and you got the nicest trim you've ever seen in your life because the trim carpenter of the town really took his time to build the thing that was for his community.
All right, man. To each his own. Like I said, there's no concrete proof of this stuff either way. That's why it's not talked about more like in our community, because we don't like to make like fixed claims. I'll call them fixed claims without proof, but it's one of those things that's super weird and doesn't match up with the timeline in many people's opinion.
All right, all I'm saying to you is like in this grand room here, which is one of the rooms in that building that I posted a picture of, at the bottom of the wall, you'll notice that that's granite. Those are not huge granite blocks. Those are granite slabs that are mortared onto a facade. All right, I do stonework. I do tile work. I know how we do it here in America. We do not build with big old block. We take it and we mill it down into a thin sheet, and then we do facade. Everything behind that is hollow. Everything up behind that is hollow. I promise you. I know how we build, how we've always built in this country. We don't do stone construction. We do hollow facade, and then we do sheet. And that's what this is. I've gotten into these old buildings. I've torn it apart. You think you're looking at something stone. It's not. I can show you remodels of them. I've tried to show it to people who say, oh, my lunch break. It's like, no, I'm sorry. This is a hollow facade, and underneath this is wood and plaster. It just looks beautiful. That's it.
I don't think that's the same ballroom. It's not got enough seats, and the views are from the side. It's a slightly different one, but it's similar. It's a similar construction type, but they had like it was like a 1,400 pipe organ and like 1,700 seats and like a set of, I forget how many crystal chandeliers that are insured for $250,000 each in this town of 1,000 people with 50 high school kids for the high school. I mean, to each his own, bro. I just don't think that makes sense, especially like in the middle of nowhere in Minnesota. If they had that much capital to inject into their community, I I don't think it would be spent on that. Much less the feasibility of making that construction happen in that town. But I gotta go. I'm gonna go play Oblivion and eat and enjoy my day. Y'all never played Oblivion, you gotta check the remaster out, dude. Peace.